down.
2, 1.
So, ladies and gentlemen, it turns out there is another method besides Pythagorean theorem and the law of sines and trigonometric ratios, and it is called the law of cosines, and it works in two special cases. One is the side angle side case, and one is the side side side. Side side side. Side side side. Side 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 case. All right? So the first thing we're going to do is actually derive the law of cosines with a little picture. So let me draw a picture. This is a non-isosceles. Isosceles makes me think of scones. Scones, I view scones as the ultimate punishment breakfast. It's just like, ugh.
What? You don't like scones? There could be some really good
They're like muffins that aren't sweet and are lumpy. They're like lumpy, unsweetened muffins. Thanks, scones. Doesn't mean I won't eat them, because if I'm hungry, I'm hungry. Did you just call scones a diaper? No? Okay.
A diaper?
Like the diaper of breakfast? I don't know. Okay. Anyways, so let's label this. So here's my ABC. Here's, I guess I can label little c. Here, this whole length would be little a. This side would be little b. And this would be my height. Am I correct?
You are correct, my friend.
And let's say that this length from here to here is x units long. Okay?
I don't like this already.
So my question for you is, how long would it be from here to here?
Half the distance.
If this was an isosceles triangle, yes, but it is not.
So a third.
No, it would
A
depend.
quarter.
It would depend, right? But it would depend on how long A is. All right. If A was 10 and this was 7, how long would this be?
3.
3. If A was 12 and this was 4, how long would this be? 8. How did you figure that out? You subtracted.
I added.
So this length is A minus X. All right.
You know what I'm saying?
So let's do some work. Let's do Pythagorean theorem of this right triangle. Actually, do I label this point? Yeah, we can label that. The point where the height terminates. We could call that point D if you want. Yes.
Does it matter what side is A minus X? Is it always on the left side?
No. We're just deriving it. We won't refer to many sketches
This is
sketches
the
like
first
this.
time I've ever seen a D, just the letter D used in math.
What about the distance formula?
That doesn't count.
Okay.
Why not?
What about the fourth point of a parallelogram?
I don't even know what that is.
There you go. Problem solved. So let's use Pythagorean theorem on this left triangle, A by 2. So I would have, what would we have? We'd have A minus X squared, right? Plus H squared is going to equal C squared, right?
Yeah, plus h squared equals c squared.
And does anyone know how to expand A minus X all squared?
I do not.
How do you do it?
My
It would be A squared minus 2AX
minus 2a
plus X squared plus, and then the H squared equals C squared. We're deriving the law of cosines. What does T stand for?
Oh, that's a plus h.
Yeah, that's a sad-looking plus
Wow.
sign. I can undo that.
That's really bad. That's
Plus H squared equals C squared. All right?
And then you add. Oh no, never mind.
Now, what if I do the law or Pythagorean theorem for this right triangle? Right triangle. God, look at that. It's a right triangle that is on the right side of this. What? Oh, wow. That's hilarious. Wow. Wow.
Right?
You started laughing. I'm like, what are you laughing about?
Yeah. So for this right triangle, oh my goodness, what would Pythagorean theorem tell us?
Yeah.
Tell us all the secrets of
Well, if you want to go,
It would say x squared plus h squared, friend, is equal to b squared.
Square.
Am I right?
Yeah, you're.
Am I right?
Am I right, guy? Oh my god, no. Might be. Ooh, would you call that a bingo? Right there by the x squared on the first left side.
It's close. It's close. Yeah, a square of a binomial isn't often a common place where that would occur. So guys, check this out. Where do I also see x squared plus h squared? Over here, right?
So you can just
So I can substitute this guy for that guy, right? So that will be a squared minus 2ax plus, and replace this all with b squared is equal to c squared.
So a plus 2ax plus b equals c squared.
So notice what I have right now. I have an expression in terms of a, b, and c, and then x. If I could get rid of this x, that would be great. So let's do that. Let's do that. Give me another equation I could write that relates x regarding any of my other stuff. How does x relate to h, for instance?
Would you do the whole thing? The entire thing?
Well, I guess we could, but it's easier to work with the right triangle sometimes. We'll know additional facts. For instance, from angle C's perspective, what is x? The adjacent leg, and what is h? The opposite. So what trig ratio from angle C's perspective compares x and h? Tangent. So I could, wait a minute. That would be true, but I just realized we don't want to relate it to h, because h is not going to be a known fact. I'd rather relate it to b, which I already have floating around in my equation here. And also then that would be the law of tangents and not the law of cosines. My bad. So x is the adjacent, b is the hypotenuse. So what trig ratio compares those? Cosine, I hope. I got it right this time, I think. Whew. So cosine of angle C is equal to what over what? X over b. So that means if I wanted to solve this equation for x, what would I do to solve for x? Multiply by b, right? And I would get x is equal to b times cosine of c. So I can now replace x anytime I want with b cosine of c. So what should I replace? Maybe this guy over here, this little dude right there. Ooh. Nope, I don't like that one either. How about one of these?
No, you touched the B though.
Yeah, I did. That's fine. It's a keeper.
Keep.
So that means my equation is a squared minus 2ab cosine of c plus b squared equals c squared. And notice what I'm left with. I'm left with the relationship between three sides and an angle. Meaning, if I know any three of those pieces of information, I can find the fourth. And notice this is also not law of sines, right? This is an entirely new expression, and this is what it says. So we know this is what the law of cosines is. Actually, it comes in three forms. the third of which will be c squared, little c squared is equal to a squared plus b squared minus 2ab cos
C
cap
squared
c.
equals a squared plus b squared, which is the blank of 2ab cosine of c.
So that's the third form. The first form will be in terms of a squared. The second form will be in terms of b squared. But instead of deriving both of those, let's see if we can figure it out on our own. So a squared is actually going to equal b squared plus c squared minus 2 times, what letters do you think would be there? BC times the cosine of which angle? Capital A, right? Because this was a capital C angle related to the little c side, right? Capital A angle, little a side. And then the b squared form will be a squared plus c squared minus 2ac times the cosine of b cos b.
Is he still alive?
Yep. He's still doing comedic tours, from what I understand.
We passed this conversation.
Yeah, if you watched some of the other videos.
Maybe.
And now, actually, check this out. This portion of the law of cosines should be a little bit familiar to you.
Oh,
That's Pythagorean theorem, right? So basically, this is saying for the law of cosines for a non-right triangle, it's the same as Pythagorean theorem. Then you just subtract this little bit of error, basically, is what's occurring, right? We're subtracting the little bit of leftover, and we end up getting the right value. So these are the laws of cosines, or law of cosines in 3 different ways of writing it, depending what we're looking for. So let's actually do one of these problemas. My students are exhilarated. Exhilarated. So let's say I've got this little triangle, and
Can you do this?
let's say I've got A, B, C.
It's easy as 1, 2, 3.
That's right. So here we go. Law of cosines. Easy as 1, 2, 3. Suppose this angle is 124 degrees. And let's say that side B is 10. And let's say that side C is 7. All right? Now, I can't use law of sines because law of sines requires you to have a pair of the A's, the B's, or the C's. And I have neither. I've got a little a, I've got a little b, and I've got a big C. So, no, that does not work. But I can use law of cosines, and the piece of information I can find will be little c. All right? And it turns out I'll be able to use this particular version. Form of law of cosines, c squared equals. So it's equal to a squared plus b squared. I guess if I'm really particular about my labels, I can be consistent there. 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 124 degrees. And by the way, the thing that messes people up with the law of cosines is PEMDAS. Oh, it's a shame. It's a real shame. A darn shame. I'm sorry I said it.
What did it?
So 7 squared is 49, 10 squared is hundo, minus, what's that, 140 times the cosine of 124. Now this is what people do, ready? They'll do 149, and they'll see this minus 140 times the cosine of 124, and you know what they'll do? They'll do 9 times the cosine of 124.
No!
Why is that bad? Because multiplication comes before subtraction. But they're just like, these would subtract so great. But they don't. They don't, guys. So be careful. Be careful. So let's figure this out. So this is 149. You wouldn't have to write out all this work all the time, by the way. cosine of 124, by the way, is, and make sure you use cosine and not sine, because you guys, for the last 3 courses, lessons, whatever, have been using a lot of sine, okay? And cosine of 124 is actually negative 0.5592. Why is cosine of 124 negative?
Because it's in the negative quadrant.
Because it's in the second quadrant, and cosine is negative there, right? So this is now going to be plus because of a double negative. And if I multiply that by 140, 78.2870.
Multiply it by 140 or
Negative 140, whichever.
no.
2870. And I add them up. Add them up. Do 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 do. And I get 227.2870. So is that the length of C? No. That's the length of C squared. So how do I find the length of C? Root. And technically plus or minus, don't forget it, but we can actually forget it this time because we're talking about the length of the side of a triangle, and a negative length doesn't make much sense. Because I'm not talking about vectors here, people, that have both direction and magnitude. So I get C is equal to 15.0760. And now that I know the side C, I've got a pair between C and cap C, so I can use law of sines to find my next angle. And then I can use triangle sum to find the third angle. I'll just do 180 minus whatever 2 other angles I have.
Wow.
So that's law of cosines. Let's just actually just do the setup. If I wanted to find angle B, what would I do?
Sine B.
Sine of B over 10 would equal sine of 124. See, now that I have that pair of C's, over 15.0760. I'd solve that for B, and then I'd find angle A a moment later by doing 180 minus C plus B. Right? And good news, guys, there is no ambiguous case of the law of cosines. It's always sure of itself. Isn't that special?
That's just swell.
All right. So law of cosines, it's kind of a good thing. It's kind of a big deal. Can solve.
You probably never heard of it.
Yeah, you probably never heard of it, but it's kind of a big deal. Let's do one more example of a different case problem. Let's say, what if I've got the classic? What if I've got a triangle 1, 2,
Yeah, little guy.
and 3? Yeah, look how cute that little guy is.
ABCs. He has 1, 2, 3.
I imagine that this is like a little bird,
With giant.
and then it's got like, I don't know, maybe this is like a little chicken gobbler right there. I don't know. What do you think? What's that called?
What's a gobbler?
An external Adam's apple? Ew, that's gross.
Yeah.
So, I don't know, let's label this A, B, C. So that way at least A, B, C, 1, 2, 3 are lined up. So I do not suspect that 1, 2, 3 is a Pythagorean triple. I don't think this is a right triangle. I believe it's oh so wrong. So what do? Well, I can actually find one of these angles. Now, let's take a look at law of cosines. Law of cosines will relate 1, 2, 3 sides and an angle. All right? So I know all 3 sides. I don't know an angle. I can actually use either of these 3 forms depending on if I want angle A, B, or C first. Let's find angle A first, just for fun. So I'm going to do the A squared equals version of the law of cosines. So 1 squared equals 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of angle A. All right? So I've plugged in what I know, and I'm solving for what I don't. Classic algebra problem, am I right? 1 squared is 1 equals 4 plus 9 minus, let's see, 4 times 3 is 12 times the cosine, I guess, all right, 12 cos A cosa. So 1 equals 13 minus 12 cos A. And then this is where people were like, oh, 13 minus 12 is 1, which they're right about 13 minus 12, but they're wrong about PEMDAS. Oh, so wrong. Because multiplication would come first. So how do I solve for A here? Does anyone know?
Don't speak.
Sin.
Don't ever say
Not yet. Not yet. I would move this 13, so I'd have negative 12 equals negative 12 cos A. Let's see, I'm kind of scared where this is going, actually. Wait. I'm not sure what's going to happen, guys.
So scared.
Oh, you know what? Oh, darn it. This is not a triangle. I messed this up. Hello.
Is Mr. Wood here?
Next room over.
Oh.
One door over. Guys, you didn't call me on my classic 1, 2, 3 triangle. Yeah, because if this is 3, here's 1, and that's 2. Those would like barely, that'd be like the situation. But that's okay. Let's see what happens here.
Live.
I'm rolling with it. Divide both sides by negative 12.
They're different units of measure. That's what it is.
So I would get cosine of A is equal to positive 1. And then I would have to cos inverse both sides, right? Cos verse. Cosine inverse. Doing the math, that makes it last. Do-do-do. Cosine inverse of 1 is either 0 degrees or 360 degrees. So this is a 0 degree angle, because 360 degrees just wouldn't make any sense, because we know that the sum of the interior angles of a triangle are 180. Please, people. So, yeah, and if that worked, then I'd be able to find the other ones using law of sines and then triangle sum. But yeah, I can't believe I gave you guys a triangle that wasn't a triangle, but we still solved it anyway. Magic. And notice, yeah, this is what a 0 degree angle looks like right there. 0 degrees.
Nice.
Classic. But anyways, my point is law of cosine. That's
Would
it.
it also be 360?
Yeah, but you can't have your interior angles add to 360. But this doesn't really fit triangle qualities now, does it? Well, anyways, Internet, I think that's good enough for the law of cosine.